Welcome back, ladies and gentlemen, to another Murph Codes front-end web development. It's been a little while, but I have not been idle this whole time, doing nothing. No, I have cobbled together a plan for our project. We're going to make a game. Now, if you're looking at your screen here and you're seeing all these windows that I have open, you're probably wondering, what in the world is this mess? Don't worry, this is why most people run with 2 monitors, and I'm only able to show you one. What we have here is the makings of the game that I'm going to be building for you live on session. We're not going to complete the entire thing today. What we are going to do, though, is continue from where we left off, talking about sprite animation. Being able to manipulate the canvas element with some JavaScript. Don't mind me, I'm just trying to clean up the glasses a little bit. They're a bit smudgy. But we're going to get on that. And last time, if I remember right, I said that in order for us to proceed, we would need some kind of sprites to work with. And in order to have the artwork to work with, you kind of have to have an idea of what you're building, right? I mean, it all goes hand in hand. So I very quickly cobbled together an idea for a game. Like most really quickly cobbled together games, I'm basing this off of some work that somebody else has already done. Don't worry, we're not just blatantly ripping off somebody else's idea. There's a very old game that was written like, I don't know, 1984 or something. It was a million years ago. But in this issue of The Magpie, which is just an online online magazine for fans of the Raspberry Pi, a little computer board that if you haven't heard of it, haven't seen one, haven't played with one, I highly recommend checking it out. It runs a little Linux operating system. You can use it to write Python code. I mean, you can use it to write any kind of code you want, to be honest. But it was just a little tiny system on a board kind of thing, sort of like Arduino, where everything runs off of an SD card, and it basically just works as an entire computer system on a little tiny credit card sized board. And I've played around with, quite a few of the older versions of the Raspberry Pi. They're a lot of fun. Um, the idea behind the Raspberry Pi project was to kind of reinvigorate the old early 80s STEM program push. Back in the day, like the Commodore 64 era, the Tandys, the old Apple IIs, upon the release of those home computer systems, there was a big push to get kids interested in learning how to write code, getting to learn computer sciences, and we saw our first real boom of young hackers, in the making. And this was very much like the War Games era. You remember the War Games movie? Um, it's along those lines. And part of that era was there were all kinds of magazines out there that had all kinds of little code things that you could write and run on your computer as little lessons for developing, and just fun little things you could build. Well, with the Raspberry Pi, um, this magazine for Raspberry Pi users also came along, and it does a lot of that same sort of thing. Every issue, there's all kinds of interesting, cool projects people have been doing, um, instructions for projects you can try at home. Some of them are science experiments, some of them are DIY projects, some of them are just, simple tutorials on how to use Linux and how to write various programs. As you can see here, these are a couple of the things a few users have done with their Raspberry Pi. One of them is using a Raspberry Pi to monitor their aquarium for things like, I imagine, temperature, pH level, stuff like that. They also had interviews with the folks responsible for developing the Raspberry Pi. So you got a lot of background information. They would also interview people who were doing interesting things, working on very interesting projects with the Raspberry Pi. Things like the various code projects and code camps and stuff that were going on. Robot fairs and things like that were trying to reinvigorate this movement to get people, interested in computer sciences again. And it's a great little magazine. Every issue is available for free for download at raspberrypi.org/magpie, I believe is the address. Go check it out. A lot of really cool stuff. And even if you don't have a Raspberry Pi, one, Raspberry Pis are incredibly cheap. So feel free to order yourself one. Not a sponsor. This is just my opinion. Feel free to order one. They're great. I have like half a dozen somewhere in a box, not very far from where I'm sitting right now. I have a robot that has one as its microcontroller. It's a lot of fun to play with. It really is. Here's an entire article about a guy who built a weather station using one, so he could, he can track the trends and whatnot. And he's even got, how you can use Python, which is a programming language we've talked about on this channel, but it's also a programming language you can use on the Raspberry Pi. How you can interact with an SQL database. Here's that one on the dude who was using a Raspberry Pi to build a monitor for his fish tank. You know, they go through all the various components that it requires, how to wire it all up, how to program it. A lot of good stuff. And every issue has this kind of stuff. I mean, they're also chock full of, like, you know, ads for various outlets for buying components and things like that. So you're never far away from having what you need for the things you're trying to build. Now, our project is way down here at the end. Oh, they also do book reviews. So, like, if you're looking for a book on, you know, programming languages and stuff, they have those. They have plenty of those. But we want to come all the way to the back of the book. Past the Linux tutorial, past the various projects people have submitted, past the countless ads, and we're going here. Stronghold of the Dwarven Elves. Now, this is issue number 21 of the Magpie. It came out like, I don't know, 100 years ago. It's in the very, very backlog of Magpie stuff. And this tutorial is actually based off of Tim Hartnell's computer game that was very early 80s, originally written in BASIC, another programming language I know. But yeah, you could buy this book at your local, you know, your local bookstore, your local computer outlet back in the day, and it would have all kinds of code that you could type in to your ZX computer, and, you know, your Sinclair ZX81s, and you'd be able to type these up and play them. Well, in this article in the Magpie, Martin Hodgson has updated the original BASIC version to work in Python. And for our project, we're going to update it to work in JavaScript. But we're also going to take it a little bit further. The Python version, which I have right here, I've already got this all typed up, so you don't have to worry about, you know, copying this down. I'm really just referencing the Magpie and all this stuff. You know, for your enlightenment, should you decide you want to check this out, you know where I got this. You can go get it, check it out yourself, and maybe do your own thing with it. But let me show you what happens when we run this. Okay, a little bit of text here. Let me see if I can. Let's make this a little bit bigger so we can read it. There we go. Okay, we got Stronghold of the Dwarven Lords. It just gives us a very simple prompt. Press enter for a new game. We hit enter. We are given this right here. This is a display. That's the map. This little asterisk right here represents us, the playable character. These hash symbols are walls. We cannot walk through those. And we've got a bit of information here. Step number 1. To the north of us, there's a wall. To the south of us, there's a wall. To the east, it's open. To the west, It's a wall. The Dwarven source beam reads 1200. Alright, so we'll figure out what that means here in a minute. Which direction do you want to move? North, south, east, west? Or press H for help? Okay. Well, it says the only open direction we can go is east. So let's type east. Step number 2. Okay, it seems we've gotten a little further away from our destination, I'm guessing, because the dwarf beam, source beam, now reads 1210. Which direction do we want to move? Looks like we have a lot more open area we can go. We don't want to go west, that's where we came from. Now, we can scroll up to check our map, but if we want to refresh the map so that we can see our position on it. See, as you can see, we stepped out from this little cove here. However, it penalized us by 15 steps. That's quite a punishment for reprinting the map. So we're going to try to not reprint the map if we can. But let's go north. Okay, that got us closer to whatever this Dwarven source beam thing is looking for by 100. So that must be pretty good. Looks like we can still go north. We can still go north. Still go north. Let's see, how many is that? 3 norths? 1, 2, 3, 4 norths. We look at our map here. 1, 2, 3, 4. So east and west should be closed off by walls. If we go north one more time. Okay, there we go. That makes sense. Now we can go east. Still says we're getting further away, though. But, I mean, we're here. And my guess is the thing we're looking for is going to be probably, like, up in this corner. Because if we move to the right, it says we're getting further away. So that means it's to the left. But it's also still quite a ways north of us, because we've still got 700 to go. So we want to get around this wall. That was 1, 2, 3, 4, 5. Alright, so we want to keep going till north opens up. Right? It says there's a wall there, so let's keep going east. 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 Up. North is opened up. That means we are here. So we want to go north until we can't anymore, and then we'll go west until we can't anymore. Alright, looks like we can't go north anymore. Let's see what happens when we try. Ouch, we just walked into a wall. So, can't go through the wall. Now we wanted to go west until we can't go west anymore. Alright, west is now a wall, and then we want to go north again. And then if we go west one more... You found the Dwarven riches in just 41 steps. Huzzah! And then, of course, it loops back around and we can play a new game. This is what we're going to be basing our game off of. However, we are making, like I said, some changes to it. For one, we're not doing a text adventure. We want to actually draw the walls and spaces so that our player can see them visually, and they're not just wandering around in the dark. The little asterisk will be our protagonist. The empty spaces will be represented by one tile that appears like something we could walk on. And the hashtags will be represented by a different tile that will be representative of a wall. And because we're taking out some of the challenge by making it so that we can actually just look at the darn map, we're going to add in an additional challenge. We're going to have bad guys. We're going to put in some enemies for us to try to avoid as we sneak through the maze. So, let us take a look at the art we have to work with. Please don't laugh at my terrible, terrible artwork, because it is terrible. My art is not great. This is what we're working with here. Alright. This fuzzy little round dude is our bad guy. Alright? He is a dust bunny. I know he doesn't have ears, but I didn't want... I couldn't make the ears look right, so I was just like, screw it. No ears. Vicious little fuzzballs with teeth. These tiles here are going to be what our map is made of. We have a normal earth, ice, and kind of a lava-y, stony thing. This first tile is a tile we can easily walk on. This is a wall represented by a rock with some moss on it. This is a frozen, icy floor with a little snowflake, just easily enough to move across. This is, I can't remember if stalactite or stalagmite is the correct thing we're looking for here. But that's going to represent the walls in our ice mazes. This is sort of a little lava-y tile that we can walk on. And this right here is our wall in the lava levels, the kind of volcanic environments. So we have walkable, wall, walkable, wall, walkable, wall. So we have 3 variations. We could have done more. We could have gone with just one. My art is not great, so I tried to do 3. And I think it turned out okay. I'm not hating it, but it could have been better. Our bad guys could have been better, but I'm not hating them. As for our protagonist, and this should give you an idea of how exactly I did the art here, because I layered these guys. Okay, when you're doing sprites or any kind of artwork, get yourself a software that allows you to do it in layers. Trust me, it's a godsend. A lot of you are like, well, yeah, duh, but like, keep in mind, I'm not an artist. I didn't know this originally when I first started out doing this kind of thing. This was a thing I had to learn. I learned it a long time ago, and it has been just amazing ever since. Anyway, this is our protagonist, the angry green slime cube. I know. Usually the slime thingy is the bad guy, and the cute fluffy thing is the good guy. I thought I'd flip the script a little bit, though. We're going to control an angry green slime cube as it moves through the maze and tries to avoid being attacked by the fluffy by the fluffy bunnies. Now, I have all of my resources dumped into this one original file. And the software I'm using here is just paint.net. If you do a search for paint.net, you can download this. It's a very simple image app that's very much akin to the old Microsoft Paint program. So if you're like me, not a very good artist, and your full experience in anything is paint, but you want the ability to do transparencies and layers, which is what I wanted, try paint.net. It's free. You can do layers. You can do transparencies. Might be a little bit of a learning curve, but everything is easily accessible online. You can find tutorials that cover the various features of this. It's not overly complicated. Sometimes it can be a little on the complicated side, like moving between layers and trying to get the program to allow me to edit the different layers as I move between them was sometimes a pain in the butt, and I found that the best way to deal with that would be to save what I'm working on, close the entire program, reopen the program, reopen what I was working on, then move to the layer that I was trying to change, and then proceed with my editing. I don't know what was stopping me after I had already been working on a layer from going to a different layer to work on that one. But, like, I don't know. The program wasn't super happy about that, so it wasn't making it overtly obvious what I was doing wrong, so I would just save my work, close it, reopen it, go to the layer I wanted to work on, and find that I could do the thing that I was trying to do just fine without any other additional steps. A little bit weird, a little bit of a workaround, but it worked, and I was able to crank out this glorious work of art. The finished product looks like this. Alright, and these are the sizes of things as they're going to appear in our game. So it's not going to be real big, but we also want this to be mobile friendly. We want to be able to fit the entire map on the screen at once. We want to be able to fit the whole map on the screen at once, no matter what screen size we're going with, whether it is whether it's a mobile game or a mobile app, mobile view screen, or a desktop that we're displaying our game on. And we're going to do a little bit of wizardry with our JavaScript to keep our map centered and sized appropriately so that no matter what screen you're playing on, it's a very similar play experience across the board. Now, I did group our dungeon tiles in with the Evil Bunny sprites animation cells. And that was just because I'm trying to keep the number of resources we have to load in to a minimum. It would have been cool if I had just thrown all of these into the same file. That easily would have worked. But I didn't. I was trying to keep the file size to a reasonable level. And this one is 23 kilobytes. On decent internet speed, that's going to be Super fast load time. This one, for some reason, is 48. I don't know why that one is so much more. Might have something to do with the density of these tiles. But again, that's not going to take a lot of time to load. Okay? So we're keeping these small, but we're also keeping them in modular chunks. The way I have this divvied up is this is our playable character. And whoop, there we go. This is our dungeon elements. Okay? These are the floors and walls, and this is basically our traps. Our traps are these little bad guys. So, we can load this in, populate our dungeon, then load this in, populate our playable character. These top two rows are basically just our idle animations. We have a left and right. We have left looking. We can make his eyes shift left and right. We can make him blink. I also did this one where he's just got the all-white eyes. I thought we could use that for when he gets hit or something. When he comes into contact with one of the evil bunnies. Or something. I don't know. We'll mess around with that for a little bit. This third row here, this is a moving to the left. This is a moving to the right. And how we're going to animate that is basically just by toggling between, like, this row and this row. So it looks like he's kind of elongating himself and then shortening, elongating himself and shortening. But the cell animations should match up, so as he's moving, we would just, every couple of tiles, we would switch what row we're in. And same with this one here. We have our idle, and we have our moving to the right. We have our idle after moving up or down, and then our moving up or down. Same thing. Here, very similar, except we have eliminated moving up and down. These things are just going to move left and right. Alright? So, we were able to eliminate an entire, couple of rows just by keeping it that simple, left and right. This row here might actually be an extra just holding still. But, idle to the left. Idle to the right. Moving to the left, moving to the right. Still. Alright, so. That's the explanation of the artwork we have here. Now, how I did this in the thing. And you don't have to go nearly as far as I did with this, but I zoomed way, way in so that I could see this pixel by pixel. Alright? My very, 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 very bottom layer, the background, I drew in the outline for the cells. I went with a 60 by 60. The black lines are on the zeros. So I know my actual image starts at 1 and ends at 59. Now, when I saved the sprites, though, I made the visibility of those cell lines, those cell outlines, invisible. I turned the visibility off for those, as well as my first layer, which is just guidelines. All right, and I did that. For my first layer, I added in some guidelines here to divvy up those cells. This helped a great deal with placement of things, because then I could just be like, okay, I'm so many pixels in from the left or right, but rather than have to count every individual pixel, I could start at like the nearest line, and I have these at every 10, and it really helps with the composition of each cell animation. So, I could have made that as just part of the background as well, but by making it a separate layer, I could turn that off and still see the outline of the cell, but get a clearer picture of what I'm looking at for my sprite. And yes, being this zoomed in, I still see the grid lines, but I can also turn those off. So, you get a better idea. And adding in these extra helping layers is as simple as just making them and then turning them on and off as needed. Just remember to turn them off when you're saving the actual asset for the game, because you don't need those gray lines showing up inside your game. So yeah, I would turn the background off, turn the guidelines off. This checker pattern, this just indicates that this is transparency. So if I were to save this right now, whatever this image is displayed on top of will show through wherever you can see checker pattern. And as you can see, that checker pattern extends through my character because he is a bit translucent. I did go with some translucency here because I wanted it to be representative of he is a slime character. He is made of slime. He's a gelatinous cube. So yes, he's going to have some translucency. You're going to be able to see a bit of the dungeon through him. Or at least that's my plan. I'm hoping it works out and looks good. Otherwise, it might just be a big muddled mess. Who knows? Who knows? This is all experimental right now. But that's how I did it. I divvied up the rows and columns so that each row represented a state of motion, each column a cell that could be accessed within that animation. However, I didn't do it super cleanly like you might see on some sprite sheets where literally every row is a cell in like a running action. We're going to be doing a lot of stuff with our cells. Like I said, this top two is sort of an idle left and right, but they're also going to be reused as part of our moving animation. And we're going to combine them with the other two rows here to get the moving effect that we're actually looking for. But I didn't want to have to double the size of this to draw similar looking cells. So that's how we're doing that. But don't worry. Doesn't entirely matter how this all lines up on the sheet. What matters is how we import it and implement it in the code. This was drawn on the exact same, because like I said, I drew all of it in the same file, the same resource file. That's kind of creepy. It's just getting worse. Ah. But I gave them separate layers. And then I just turned off the layers for the slimes, so they were not visible when I saved the resources for the Dust Bunny. If I added more characters, I would just add them in this file right here, and then save them as PNGs with only the layers that I want to be a part of that composition. So, like, this is a PNG file that only the parts that are for the slime cube layers were visible. And my other one, if it's gonna let me, where is that? Where's my other one? This one. Buried behind all the stuff. That's where it is. This one is just the dust bunnies and dungeon cells layers visible. And so that's how I did that. You could do it however you choose to do it. You don't even have to use paint.net. Back when I was doing this kind of thing before, I used GIMP. I had originally intended to use GIMP for this project, but it's been so long since I used GIMP, I have kind of forgotten how. I'm not gonna lie. I do not remember how to pull off the effects that I was looking for in GIMP anymore, just because it's been so long since I've used it. But Paint.net, my backup image editing software, had all the capabilities I needed and operates very similar to Paint. So it wasn't like I had to relearn a whole lot to get this done in the short time that I had to get this done. Oh, so that's how we got here. We do not want to save any changes to that. That's how we got here with these two files. That's how we're going to represent the tiles and our character and the new additions to this little Stronghold game, because we're going from text editor based, from a text-based game, to actually having a map that we can see and real challenges. And we're going to have to also program in a little bit of AI for the bad guys to... I mean, it's going to be a really simple, like, if we are on the same row, because they don't go up and down, but if we're on the same row, they turn vicious and seek us. The only way to escape them is to quickly move up or down to a different row. That's how that's going to work out. It's going to be a very simple, very stupid kind of AI, but nonetheless, it will add in a little bit more of the challenge that we're taking out of the game by making it so there's no punishment for looking at the map, because the map's always going to be visible. And we're going to have, instead of this whole asking which direction you want to move, it's just going to be mapped to our keyboard. The WSAD, WASD keys are going to be mapped to our north, west, south, east movements. We're no longer going to have the Dwarven source beam. Like, there will be an exit to our map, a hidden exit that we're trying to find. But, I don't know, we're going to call it, like, slime senses or something. I don't know. I honestly don't know. We'll figure something out. So anyway, how does the map get created? Well, as you can see here, it is not an identical map every time. Okay? You see it's a little changed, but not greatly changed. Okay, it's very, very reminiscent of the map we just did. If we look at our Python code, these right here are the data points that are making up our map. Alright, this is just a simple grid. And then there is some math here that randomizes some of the cells to modify them. And the result is this. We're going to try to replicate that in our JavaScript. We're going to start by making it text-based and print it to the console. And then we are going to render it by having it read, is that a hashtag or a space in that cell? And if it is, in our canvas, we're going to print the appropriate tile. Either a wall or a floor space. So it's going to be just a very simple translation, but almost the most direct part of this this code, because we're just going to take the map building functionality from this and we're going to try to turn it into JavaScript so that we're printing this exact same map to our console. So that's how we'll be doing that. Because, yeah, this is a very simple script, as you can see here. We have a little bit of setup where it sets up that grid. Here, where it randomizes the map. Here, where it prints out the map. Here, where it takes in our input to move and moves us through the map. And then here, when it's detected a win, printing out the message that we found the treasure. How this is going to work in our game is when you find the exit, you'll be transported to the next dungeon. Alright, you'll move through the map until you find the secret exit, which is not going to be immediately visible. We want to keep that bit of challenge. But what it will do... I closed it. But you remember the three different kinds? The dirt, ice, and then sort of lava, volcanic tile themes. It'll move to a different theme. So that'll be fun. We're gonna have some fun doing that. I think we're done with that for now. We're definitely done with this for now. Oh wait, no, we wanted that. We wanted our code. There we go. But we can minimize it for now. So, real quick reminder of how we're doing things on the front end of stuff. We have our normal website, which still has our Ajax loaded kittens file. We still have our soundboard. That's probably a little loud. Don't worry, we're not going to mess with that too much. But that's all still working. We have this launch app. Because if you remember right, the last time we saw it, it looked a little like this. We'd hit the hamburger menu to drop down the actual menu here. Hit the launch app. And it loads this black screen that is our canvas element that's being resized to our browser window, to the exact size of our browser window. So we never have any scroll bars. It is literally just the exact size of the viewport every time it loads. So that means we have the exact size of the viewport, which means with a little bit of math, we should always be able to find the dead center of our viewport, which will be handy for keeping our map on the screen, regardless of if this is going to be a desktop or mobile browser. We're going to map our movement to, as I said, WASD, but we're probably also going to map to touch up, down, left, right, like the regions of the screen, so that if you're playing this on a mobile device, tapping the top of the map should move the character up. Tapping the bottom of the map should move the character down. Left and right should move him to the left or right. And so you should be able to play this on either a mobile or desktop browser, no problem. It's going to be some very simple stuff. Very simple translation. Now, how do we import our image so that we can actually see it? Because it's great and all that we have our Sprite files here. But we can't do anything with that, can we? Not without importing it into our code. And then how do we keep from importing just the entire image all at once? Well, let's go back to this part here. You remember how when we reload the canvas, we recreate this canvas element, and then to clear the board, we have to take the context of that canvas element, which, if you remember, reload and then clear board. Here we're getting the context, get context 2D of our canvas element. And we probably didn't talk about this as much as we could have, or as much as we should have. And let's remedy that. What's happening here is we are on this page, which only has this one big canvas element named Canv. It's given the ID of Canv when we create it, because if you recall, the entirety of our program loop right now is to just, anytime it detects a resize of the window within the root element. Yeah, within our root element here, it'll erase all the child nodes and just create a canvas element of the exact viewport size and shove that in there. And then if we resize it, it erases all the elements again, creates one canvas element, shoves that in there. The only elements it's ever erasing is the one canvas element we've created. And it does this on a loop. Every time it detects that we've resized our window since the last loop, it erases the canvas, puts in a new one that is the exact size and width, or height and width, of our viewport. So it takes up the whole screen. Now, from this canvas element, though, in order to draw on it, we have to get the context. And the way you get the context is with the method of getContext, and then it takes just one argument of 2D, which means two-dimensional. I don't know if three-dimensional is currently available or if that's just a thing that they're planning at some point. But, it might be a thing that they're going to do. So, once we've done that, we clear the board by feeding the canvas and the context to our clear board function, which just takes the context, changes the fill style to our default background, which we have set as a constant up here of black. And it draws a rectangle starting at the 0, 0, going to the canvas height and width. That's why we needed to feed canvas, our canvas element, to this function. We need that canvas height and width. And it just draws a rectangle on the context of that canvas. That is our default background to cover up anything that might have been there before. So we're literally just constantly drawing over everything that we've already drawn. And we do that every time we're updating something. When does the update happen? Every time we're at a new frame. How often is there a new frame? About 30 times a second is how often we're going with that. It's a low frame rate, but it's still a decent enough frame rate for our purposes. It'll still make a playable game. Now, how do we draw a single cell of our sprite onto our canvas? We can use the draw image. Method of the context. Just like in our clear board function, we're using the fill style and the fill rectangle methods. All of our drawing ability comes from the context of our canvas element. Now, this is going to take several arguments. Since we don't have an image element loaded in, what we're going to want to do is a little bit tricky, okay? We're going to want to create an image. Now, what you could do is you could take an image that already exists on the page. Or you could do what I did in the in that tarot app that I built that I showed very briefly. And what we're going to want to do is we're going to want, if I remember right, sorry, I got to try to remember the order of arguments here. Ah, yes, okay. Okay. So what we're doing is in our JavaScript code, we are creating a object for us to play with. We're calling it slime. That's going to be our protagonist. We're setting the source of this image to the sprite sheet. We're just going with the whole sprite sheet as the image source. Now, in the context of our canvas, though, we're going to draw this image, right? And there's a few, well, more than a few. There's a few arguments that this can take as well. So the first one is going to be the image. The second argument is an optional argument, but it's where to start the clipping. Now we are, and that's along the x-axis. Since we know our image technically starts at 1 instead of 0, because 0 is going to be empty. That's the space where we had the black lines, the black outline for our cell. We want to just start at 1. We're going to clip that to the first pixel. And same along the y-axis. And then we want the width of the clipped image. We know he's 58 pixels total, because he goes from 1 to 59. And that's along both axes. And then the next two coordinates are where to place the image on the canvas. Now, since this is a canvas element, we're going to go at the half point of our canvas minus half of our sprite width. And then we're going to do the same for the height. So what's that going to do? Well, what this does is it takes the canvas width, divides it in half, but that would be the top left corner of our sprite if we just stop there. We want the middle of our sprite to line up with the middle of our canvas. So we're going to subtract half the pixels of our sprite so that he's moved over just that many pixels to the left and up. And hopefully all of this works to present us with nothing. Why nothing? I don't know. Let's take a look. Let's take this out of here. We'll put this up here for now. Okay, so we've got the right path. Okay, it's probably because it's not loading the thing. So, let's give us a 10. There we go. Yeah, notice our complete lack of anything here. What we need to do is get that to reload. So, let's see. Settings. Clear data. Reload. Okay. But as you notice, there's still no image there. Seems to be indicating that there is a problem with our code. So what's going on here? Failed to execute draw image. Overload resolution failed at update. Let us copy that. Paste that. Okay. Doesn't seem to be wanting to load our image in, so here's what we're going to do. We're going to drop that into there for now. Actually, let's drop that here for now. I do have a workaround for this, but to get this to work for now, we're just going to do this. All right. So we're loading in the actual image here as an element on the page. So if we reload this, it's still doing it though. I don't understand why it's still doing it. Hmm. It's not working in JavaScript or in Firefox either, which is kind of weird. But it is giving us a different message. So let's see if we can get some information here. that's not really helping me too much here. So let's try something a little different. All right, instead of, we're going to do SRC. All right. No idea if this will work. Doesn't seem to want to. Oh, so frustrating. Um. Hmm. I don't think there's an element to. I don't think there's a method to get it to load. I think it's just supposed to load. Hmm. Trying to remember how to get this to just load. Let's see. Okay, the other thing. I mean, I know that's not going to change anything. That's just... few pages. Okay, so it is updated. But apparently our image isn't loading, and I have forgotten how to get it to do that. Okay, I have an idea. Will this work? I don't know. Maybe. We'll not know until we try it. Slime is not defined at update. So we need to pass our image somehow. Hold on, I better check the order of things here. Script is our first one. That actually defines when this happens. Okay, so that should already be declared. And what we want to do is, we've got it there, so args dot, is it what is it, append or is it push? I forget what it is on the thing. I forget what it is. Push. That's what it is. It's push. So we're actually going to change this to args push new image. Now, is that arg's length, or should that be arg's length minus 1? Maybe. Now, what's this going to do? This should allow us to use the image as part of our global argument list. And then in our app, we should just be able to go args. Let's see, which argument would that be? Because in script we have 0, 1, that'd be 2. This is getting a little convoluted. A little, out there. But we need some way to preload and pass around this image within our script. And we're passing args in everywhere. And it's not saying args is undefined. So args has been defined. Args is a valid thing. We've used args previously to turn sound on and off, enable controls and whatnot. So hopefully by feeding args our image object as an element, I don't know if I've got the math right there, so let's go with args 2. Let's go straight to 2. And script. I don't think I need to do anything in here. Still didn't do it. Okay. Okay. For some reason, our image just isn't loading. What is that saying I'm doing wrong? Did I misspell width somewhere or something? Okay, our image is loading. As you can see, it's there. Okay, are we getting a different? No, it still says it's overloading. But why, though? Why is it overloading? I don't understand. Am I trying to call the drawing context too soon? Is that what's going on here? All right, let's try this. If args 3 equals true. All right, and then we go here. Okay, this is probably not going to work. I honestly have no idea if this is even close to working. But what I'm hoping to do is set a flag in our arguments list that waits for oh, you know what? Better yet, do it that way. Okay. This is really quick and dirty and probably not going to work. But what we're doing is we have the two Boolean values as our 0 and first elements of our array, the args that gets passed around and seems to work just fine. The third element is our image. But apparently, because of its size, it's not loading quick enough. I didn't think it was that big, but whatever. So, we're adding that image still as our third element, element number 2, to our array, our list, so that it can get passed around as a global, be used everywhere. But we're setting an event listener so that when it loads, the next value in our args list is set to true, and then we are tacking that flag immediately onto our args list as false to say, hey, don't draw until. Okay? Hopefully that works. Okay. It's cleared up all of our terrible error messages, at least. But for some reason the image still hasn't loaded yet. You know, this wasn't supposed to be this complicated. I'm not sure why. I'm not sure why the image hasn't loaded. Like, as you can see, it's there. The element is there. It exists. Huh. But it does seem to want to evade every attempt of mine to just get the darn thing to show up in the canvas. To be drawn on the canvas. It's there. It exists. We're pulling that source, and as you can see here, it is a thing. It's there. That's the thing. It shouldn't take this long to load it. And we're even taking that element, pushing it onto our thing. Drawing it here. Maybe I need to do that. I don't know. Let's try it. As soon as we set that, it's overloaded again. I got to get to the bottom of this canvas rendering overload resolution failed. So that's not the same thing that we're dealing with, though. That doesn't seem to answer my question. That's not helping. That didn't help either. Here we go. Okay, it is an image. That's the image. If there's anything we can use here. On load, we have a function of not really anything. Okay, so for whatever reason, I just can't get this darn image to load into the memory of the thing. Is undefined. Huh. Well, folks, how long have we been at this? 2 hours. And we can't get the darn image to load. Yeah, I just don't know. I don't know what its problem is. It should load just fine, but it refuses to. I mean, the nice part is we're no longer getting an error, but we're also not getting an image. So, that's a problem. Okay, so we've kind of hit a block here, and I could continue to beat my head against the wall, or we could end here, and I can research the solution over the next couple of weeks, because it's got to be something stupid. It has to be. It has to be something incredibly stupid, and I'm sure I can figure out what that something stupid is if I just take a week off and come back to this. Like, I mean, during that week, obviously, figure out what the heck the problem is. And I don't mean like taking another week off from my channel or anything. I mean like, set this aside for now. And hopefully when we get back, I will know what the heck is wrong with it. Because, yeah, we're not finding the answer that we're looking for. We're finding a whole bunch of Stack Overflow entries that are for very specific situations where they're trying to do it differently than what we are, and I don't think that their solutions really get to any kind of explanation that will clarify why we're getting the result we're getting. However, I have worked with images before, numerous times. This right here is how I did it previously. I have this tarot deck object. I have a layout that's an array. I have cards that's an array that are objects. They have a name and a source. And then when I initiate the deck, initiate that tarot card object, it goes through the list of cards, creates an image, sets the image array to nothing. Reads in the sources. But for this one, if I remember right, I went with a... On the tarot, like every single one, every single card is its own image. And look at the size of those. Like, that's not a whole lot different than what we're looking at for the size of these. Can I get some properties on that? No? Not gonna let me have some properties on that? Alright, let's take a look here then. Properties. See, that's not a whole lot different than that card size. So I am not really sure. I am not really sure what is going on here. This should be visible. And if I go to... As you can see, it loads just fine here. But once we're trying to use it here, it doesn't want to do it. So I'm going to see if there is some way that I can potentially get this to friggin' work. But it'll probably take till I get back. Unfortunately, we're starting a new schedule here. It's going to be, it's probably going to be 2 weeks till we're back to this. And I feel like, we've kind of had a waste of a morning because the one thing I want it to do, draw this stupid picture on our canvas, it refuses to do it. Erg. No idea how frustrating that feels. Because that just is super dang frustrating. I don't know why the image doesn't want to load. I've tried every possible method I can think of, from having a preloader function to passing it in as an argument so that we have global access to it. I don't know. I don't know what else to try. So I'm going to have to kick this one around for about a couple of weeks to see if I can figure out what's going on here. But what we're supposed to be able to do is clip out a part of the image as our sprite and draw that. I can't even get any of the image to draw at all. I don't know why I'm getting that overload error. I've done everything I can to ensure that it loads as an image from actually making it an HTML element and pulling from that, which is supposed to work all the time. And the image, as you saw, it does load when it's used in HTML. But apparently pulling it from the HTML to draw it on a canvas doesn't. And I don't know why. I don't know why we're not able to draw to our canvas element. So I'm going to figure that out. And we will be back in 2 weeks with that solution. Hopefully. Otherwise, I'm just going to set fire to the whole internet. All of it. Ah! Rage. But you know, this is how programming goes sometimes. Sometimes you just can't figure out what the heck is going on. And you beat your head against the wall for hours and hours and hours, only for it to not give you any kind of hint as to what the heck it's not doing properly. I don't know what step we're missing. I can't figure it out. So, because we can't figure it out, we're just gonna walk away from it for now, and we'll come back to it another time. And hopefully, when we come back to it, we'll have a solution that works. It ticks me off. Because one of these methods should have got it to work. Should have gotten it. It should have. One of them should have. I don't know what I'm forgetting. I don't know what I'm missing. Yeah, I don't know, man. There should be a happy little grouping of green slimy cubes bouncing around the screen there. And there's nothing. There's absolutely nothing. So, I don't know. And at 30 frames, like, it should be able to render that image before it clears the screen, and it shouldn't be feeding us an error. It should not. And this whole overload resolution failed thing seems to stem from some kind of issue with the image not registering as an image in the context of the draw image method. But what we're giving it is literally what we're pulling from the HTML. It's the image HTML item right here. Like this right here is what we are feeding it. It is an image. That's all it is an image. But it's not accepting that. So, I'm just gonna have to tinker with it till I can figure out why this works when that doesn't. Okay, so there's a Tarot script, a Tarot JS, and a Tarot main. The Tarot JS is the Tarot deck object. And it's literally just the declaration of the object itself. And this just has all the functions for drawing it. And we're literally using the same functions for drawing. So I don't know. I'm not seeing anything here. I mean, we call this tarot deck init up here, and all that does is in our tarot object, our tarot deck object, we create this list of images. And assign these images the source that's already listed here. So I don't know, maybe that's something I'm gonna have to just look into. I don't know. We might have to get complicated with this. I was hoping to avoid getting complicated with this, but we might have to get complicated with this. Anyway, I'm gonna go make some lunch. We'll come back to this in 2 weeks' time. And hopefully at that time I will have something that works. Because this is just... This is frustrating. This is really frustrating. I don't understand why this doesn't work. Because it absolutely should work. I mean, if this works, and believe me, this works. I have tested that 800 different ways, and it works. And our image still loads. Like, we can get our little slimy dudes onto the page. And if we can get it onto the page as an image... Yeah, we can get it on the page as an image. It's rendering as an image. Like, I don't know. I just don't know. All I do know is there is some disconnect between this file and the context of this canvas element drawing it. But look at this. Even if we move this around, our image does get drawn here because, I mean, we have it right here being drawn on the same page. It's not being drawn on the canvas, mind you. It's being drawn outside of the canvas. And if I show you that, that's still resizing the... What the heck? No. What are you doing? It's resizing the canvas to cover that element. But as you can see, like, it is its own element there. It's underneath. It's underneath the canvas, but it's there. It does exist. And because it exists, because it's loaded in, like, it should, in theory, be something we can draw on this canvas. But for whatever reason, we can't. And I don't know why we can't. And it is frustrating me to no end as to why we can't draw it. So... Okay, well that did something. I don't know why this is now all of a sudden working. I don't know. It's got to be the number of arguments. But the thing I don't understand is how do we do the clipping then? Can you, though? Can you really? I really am starting to wonder if that's possible, because it does not seem to be possible. Alright, so the clipping X and Y. Clip width, clip height. Position it. No, no, that did not do the thing. I mean, it is the right size, but it's not clipped, it's shrunk. And it's almost the right size. It's not quite the right size. So, ah! There we go. Numbers. Progress. We've made progress. Woo! We have our little slime boy on the canvas. Good Lord. That was a struggle. That was a struggle. All right. Now, because we can't seem to interpret what we're reading properly, Okay, I don't have to worry about all that junk. Let's mess around with some parameters, shall we? Let's go 61. 61? Now, this should make him look to the right. Hey, how about that? This should make him look like he's kind of jiggled to the right. Okay. Now we're starting to get somewhere. Now let's say we want to move him down from that top corner. Okay. We can move him. Let's move him to the right. Hey, we have motion. Okay, so we're finally starting to see some real progress. Finally. I'm not exactly sure why it was so complicated. I'm pretty sure I'm still working with the same number of arguments. I don't know what exactly I have changed here. This is the coordinates for him, though. This is the X and Y coordinates. So if we did... Can't really see him. So let's do there, because we moved him off the screen. There we go. Now he's in the center, where we want him, where he should be. So we can move this back to that, and there we go. Page source. Style. Reload. There we go. This is what I've been trying to get to. This right here. This is where we've been trying to get to. Just being able to draw this little green slime cube on this black background. It has been 2 hours and 42 minutes. Frustrating. Very frustrating. That's all I can say. Very frustrating. But anyway, as you can see from that big sheet of sprites, we are able to pick up the single individual cells that we want to display. And our character, even though this is being constantly refreshed over and over and over again, screens wiped, character drawn, screen wiped, character drawn, screen wiped, character drawn. It just looks like a steady image. And as you can see, we no longer have any weird error messages going on here, which is kind of nice. As we resize, our little dude still stays to the center of the screen. No matter how big that screen is, no matter how small, no matter what dimensions we give it. the next part, the next part of our little adventure is going to be moving him around the screen with controls, having him animate individual cells as the animation progresses, it displaying the next cell in the animation sequence that we want. For this, we are going to want to set up a character object. And then as properties of that character object, we're going to want to give them coordinates. We're going to want to have some kind of index for what cell. And we're going to want to have some lists of the various cells that are going to be loaded in sequence for the actions so that we can page through those. That'll all be next time, because I'm already at my limit for today. I need to go make some lunch. I've got things I've got to get done today. This has been a frustrating endeavor as it is, but we actually got to where we were attempting to be. Despite the fact our little slime sprite really put up a fight getting put on the screen. He really put up a fight. Now that we've got all that sorted out, though, the rest should be easy. Because we only have to load that other batch of sprites and reference that, draw our map in the proper place after we've created it, and for that we're just going to try and duplicate that Python code for the map creation. And from there, we're gonna tinker with the parameters that allow us to move around in the map so that we can make this guy move around. And using the animation cells, it should look like he's actually moving around in the game. Yeah. A whole lot of fun. Whole lot of fun. Join me next time as I beat my head against a wall, probably again, to try to make any more further progress on this weird little game we're making. If you have any questions about coding, or if you just want to make fun of how bad I am at it, go ahead and join the Discord. The link will be at the end of the video here. I'm always happy to answer questions. However, I'm not going to build your entire project for you. Okay? If you're working on a thing as part of some boot camp or whatever, keep your questions short and sweet. Be looking for something definitive and like one individual thing, not a how do I make a Facebook? I'm not going to walk you through an entire project. I just won't. I have other things to do with my life. Okay? So, you know, if you're going to pose questions, think about what you want to know specifically. Have a specific question, a specific thing in mind that I could help you with. That isn't going to be a whole new project for me to take on. All right? And if you don't know the scope of the thing you're asking, then expect that I may tell you it's beyond the scope of a simple answer. Things like how do I write an if statement, a proper switch case, simple stuff like that, easy enough to do. If you want just some general, point me in the right direction of how to find out more about whatever, I can help you with that as well. No problem. I don't mind helping people out. I don't. I just, I always run into that when I offer to give advice and stuff like that. I always end up with somebody looking to have me either collaborate or just flat out make them a thing. Like a whole big old project. And there's only been a few times when I've actually offered to make somebody something, but it's usually I approach them and be like, "Hey, could you use a thing of this sort? I could make that for you. Would you like that? I'll go ahead and do that if you want." Um, it never happens the other way around, where someone approaches me and, "Hey, can you make me a Facebook? Could you make me no, I don't do that. I'm not doing this professionally, and if you're not going to pay me, I'm definitely not going to do this professionally as a, just a, I'm not a genie. I'm not a, not gonna Santa Claus you a new app because you want it. That's not how that works. A lot of changes coming to the channel. We're gonna go from a Monday, Thursday gameplay session to Monday, every other Wednesday gameplay session, and these coding sessions are gonna be every other Wednesday. On the alternative Wednesdays to our code sessions, Fridays will still be a gameplay, but that's going to move from being The Legend of Zelda Breath of the Wild that we've been making our playthrough on to a randomly selected game from my library, because I just have so many games. So many games. Mondays and Wednesdays, the gameplay sessions will still be our attempts to play through entire franchises, because I have a few franchises that I really enjoy that I want to play through. If I ever run out of franchise entries to play through, we'll probably just do random gameplays all the time. But I doubt that's going to happen anytime soon, because we still have The Legend of Zelda. We're still working through Metroid. We could do the entire, or most of, or at least a large portion of the Super Mario Brothers franchise. Maybe even do the No More Heroes franchise. That's a fun one. Batman Arkham series. That would be cool. I mean, there's so many gaming franchises. It's hard to even pick what I would want to play. We could do Tomb Raider if we wanted. We could do Legacy of Kain. Kind of a deep cut there. We could do Elder Scrolls. We could do we could do the Portal games. BioShock. We could do, I don't know, I might even have Half-Life in my library. I don't even remember if I have that one. I think I do. We could do the Doom series. Quake. All sorts of stuff. There's a lot of franchises. A lot of entries in those franchises. And, yeah. So we're going to keep doing that Mondays and every other Wednesdays. And then the alternate Wednesdays are going to be this coding thing as we continue to progress through making this game for the web browser. At some point, we'll get back to working in Python. I've got a few things I want to teach regarding that. We made a CRUD application, create, read, update, delete. Sort of like very simple, comma separated values sort of database thing. Very simple. Very simple. Not like a full relationship database thing like what you get with MySQL or something like that, but just a very basic, like, table maker kind of thing. And in this front-end development thing, we've shown how to take data that we can generate with that and import it into our web page. We've shown how to include sound. We've shown how to make a responsive web page. We've shown how to do a little of that action. Although I don't know why that's suddenly jutting out like that. That's a bit weird. And now I'm showing you how to make games. How to make games that you can play in your web browser. Although, as well as it's going. Do I have a hidden? I'm pretty sure I have a hidden. Hidden. Yeah. You know what? Let me try something. Let me try a thing. Just real quick. I'm okay with that. I'm okay with that. And then we're going to do... I know I keep saying I'm going to sign off, and then I just keep doing more stuff. But... while I have this working... I kind of want to take care of a couple of things. Okay. Now, we're not using that onload thing anymore, are we? No, we're just drawing. We're just drawing. So, let's go back into here. And let's go with args push document dot get element by ID dust. Ta-da! I'm a wizard! Alright, so we've added our sprites to our canvas. Next time, we'll actually get to animating them. Using more than just manually manipulating the elements here. But now that we've got it working, we are a step closer to actually having our game doing stuff. So next time we will load in our tiles, draw our map, display our map on the canvas, and then put our little characters over this map. Hopefully set some sort of boundaries so that they can detect where they're able to go and where they cannot go. And possibly even set it up so that they can detect each other. So we have some kind of either collision or have the AI for the enemies respond to us being in the vicinity of them. We'll see how all that goes. But large hurdle cleared today, guys. We managed to get our characters drawn on the screen after a whole lot of frustration. Just so much frustration, guys. Just so much frustration. But anyway, that's it for today. I will see you all again on Friday for some Legend of Zelda Breath of the Wild. I'm not sure if we're going to keep playing or if we're going to keep testing out some glitches or if we're going to attempt master mode. I have to see if there's any other glitches that are super interesting. I think we were going to try that whole shield jumping thing that I had seen, the clipping. I don't know. We'll see. We'll see. It sounds to me like a thing that I already know that I'm probably not going to get right without a lot of practice. So, who knows? But join me, won't you, on Friday? Find out what happens. And then next week, Metroid on Monday. We're playing Metroid Fusion. Metroid Prime on next week, Wednesday, instead of coding session. And the week after that, we'll get back to the coding session. And we'll hopefully have a way to display our map and display our characters on top of the map. And hopefully this will be all kinds of fun. Fun, maybe? Who knows? I don't know. I'm just guessing. So yeah. We'll see you then. And until then, have a great one.